Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So far in this course, as you are aware, we have completed two sections of this course. Casting we have completed and welding we have completed. So this is the last section, that is a metal forming. In that two sections are there, bulk deformation and sheet metal forming. So both we will discuss in this module, and we'll try to complete this as soon as possible, and we'll try to complete it cover in 8 to 10 lectures, and then this course will be completed. So today we'll start with metal forming. We'll see what metal forming is and then how it is being classified, and one by one we'll see what are the processes there in bulk deformation, or what are the processes there in sheet and also sheet forming. And also we'll see, I will start with the hot and cold working. We'll see what is the meaning of hot working, what is the meaning of cold working, and what are their advantages and disadvantages comparatively. So that's what we are going to discuss in today's lecture. So we'll start with the metal forming. Metal forming processes. We'll define what is the meaning of metal forming, and then we'll classify metal forming processes. And it will be in two category: bulk forming processes. In bulk forming, many operations are there like rolling, extrusions. One by one we'll see, and then we'll see sheet metal forming. Okay, in that also we'll see what are the processes we'll covered in this one. So one by one we'll see, and finally at the end of this lecture we'll cover what is the meaning of hot working and what is the meaning of cold working. Hot and cold working processes. We'll define this one, and comparatively we'll see what is the advantage of hot working and what is the advantage of cold working. Similarly, what is the disadvantage of hot and cold working process. So we are starting with the metal forming processes. We have already discussed in this course casting, and we have also discussed welding. In casting, we have already seen we used to actually melt solid, whichever the material we are going to cast. So we used to melt this one, and already defined mold was there. In that there was a mold cavity that we used to prepare with the pattern. In that mold cavity, that molten metal we used to pour over there, and after pouring we used to leave it for some time, so that if there will be sufficient time left with, so it will be solidify over there. Once solidification is over, we used to break this one if we are doing sand casting. So after breaking, we used to take out the product whichever we have casted, and after trimming and removing whatever the gating systems are there, that part is casted. So what was there to change the shape and size what we want, that final shape we want or final product we want. For that we need to melt the material. In welding second that we have studied, we used to melt, and other processes were there in solid state joining, but to join the two parts together. But what we are going to study in this one, in this metal forming, we no need to melt the material, or we no need to join the material. What we are going to do in this, different forces will be used to deform the material, and through that we are going to change the shape and size of the material. For example, this stylus is in my hand. Suppose I have to increase the length of this stylus. So what I will do, I will apply a tensile force from both sides. I will pull this apart. So what will happen, its length will increase. The most important thing is, as we are changing its shape permanently, that will be a permanent deformation. For that, one thing need to keep in our mind, whatever the yield strength of this material is, we have to apply the force or the load that should be more than the yield strength of the material. Then and only then there will be permanent deformation of the material. Okay. So if I have to increase the length, I will apply tensile force. Okay, now from both sides. So what will happen? Its length will increase, but its cross-sectional area will decrease. Okay, but if combined effect we will see, there will be no change in the volume. Okay, because whatever the decrement will there in the cross-sectional area, that will be compensated by increase in the length. So finally, we'll see volume will remain constant. So what happened here? We are not melting the material to change the shape and size. What rather we are doing? We are simply applying a force to change its dimension or change its shape. We can do other things also. Suppose we have to increase the cross section area and we have to decrease the length. Then from both sides, we'll apply compressive force on this stylus. So what will happen is cross sectional area will increase and length will decrease. Here also if you'll see, there will be no change in the volume. So what I mean to say, in this all the metal forming processes, whether we are doing the bulk deformation or we are doing the sheet deformation, in all the processes, we are going to use different type of forces or combination of different type of forces to simply deform the material and bring it in a particular shape with the help of die or whatever the things are. But the important thing is we are going to apply the force or combination of forces to change the shape and size of the material, okay, without melting it, without joining it. That is the fundamental thing in this metal forming processes, okay. So in metal forming means there will be plastic deformation. Of course, different setups will be used, different equipments will be used, different machinery will be used to deform the material. If it is a metal, we know manually we can't do that. If I'm simply telling this is stylus, holding this is stylus. If it is a metal, it's not possible for me to pull it. Okay, now so who will pull that? So machines are there, equipments are there. With the help of that one, we'll do this and we'll deform the material. Okay. So now we'll start with the metal forming. So what is this one? Large set of manufacturing processes in which material, this is important, material is deformed plastically to take the shape of the geometry. Okay. So whatever our requirements are, accordingly our geometry will be there. For example, die will be there. We will apply the force, material will be plastically deformed and will take the shape of that one. Tool used for such deformation are called, it may be die or punch. Die means the shape that we want, just like mold, and punch, that is a mean through which we'll apply the force to change the shape. Okay, depending upon the type of the process, of course. Different processes are there. One by one, we'll see. Plastic deformation means simply stress will go beyond the yield strength of the material. The stresses beyond the yield strength of the workpiece material is required. Obviously, if because we have permanently changing the shape of the material, so there will be permanent deformation or plastic deformation in the material. And if there is permanent deformation or plastic deformation, so obviously the stress or the load that we are applying on the material, it should be more than the yield strength of the material, so that yielding will start. Okay. Now it is characterized or divided in two parts. This metal forming processes is divided in two parts. Okay, one is bulk metal forming and another one is sheet metal forming. So here also classification has been given. This metal forming is divided into two parts. This is bulk deformation and sheet metal forming. In this bulk deformation, rolling process is there, forging process is there, extrusion is there, and of course this fourth one is wire and bar drawing is there. In sheet metal, we have bending operation, we have deep or cup drawing. Okay, then shearing processes are there, and some miscellaneous processes are also there. So these are the way how it is being classified. This, so this sheet metal forming is classified in two parts: bulk deformation and sheet deformation. In bulk deformation, according to our syllabus, we have rolling processes, forging, extrusion, and wire and rod or bar drawing is there. And in sheet forming, we have bending, deep or cup drawing, and then shearing. Different shearing operations are there. So one by one, we'll take this and we'll discuss all these processes. So in classification of bulk forming processes or bulk deformation is a severe deformation. Severe deformation means we are going beyond the yield strength of the material, that the load we are applying, that is more than the yield strength of the material, so that there will be different stages in the material. We know through the stress strain diagram of any material, different stages will be there in a material. Suppose this is a mild steel and this is the stress strain curve. So we know once yielding will start, this is the upper yield, this is the lower yield. After that, material is not going to come back at its original state. Always there will be a permanent deformation once the load exceeds the yield strength of the material. And as we are going to change the shape of the material, so obviously there will be permanent deformation over there. So whatever the load or the stress we are applying on the material, it should exceed the yield strength of the material. Okay. So in bulk deformation, there will be severe deformation. Okay, na? resulting in massive shape change. Yeah, of course. The surface, this is very, very important. Surface area to volume of the work is relatively small in bulk deformation, but it is more if we compare in sheet forming. Mostly done in hot working conditions. Hot working condition means the working temperature on which we are deforming the material will not be at room temperature. It will be beyond the recrystallization temperature of the material. Okay, recrystallization temperature is generally considered a temperature more than the 0.5, matlab half of the melting temperature of the material. The range is generally defined 0.3 to 0.5 of the melting temperature of the material, but that is not a fixed value because it depends on many parameters. Okay, so we'll start with as I said, in bulk, four total processes are there. That is there in our syllabus. That one by one we'll take. But just briefly, we'll see what is the meaning of that. First one is rolling operation in bulk deformation. Rolling means two rollers will be there. Not more than two rollers also will be there. But here in diagram we have shown, we have these rollers. It is rotating on its axis. Okay, so this one is rotating and this one is rotating. It's very important to understand the sense of rotation, because this sense of rotation will decide, or it will pull this material that we have to deform inside. And what will happen, from both sides compressive forces will be there. This is known as the initial thickness of this workpiece. Okay, now so suppose this is hi, and you can see here this is the final thickness, that is hf. So Hi is greater than Hf, means this material has been deformed. So if a plate we are putting over there and from both sides it is going inside the roller, it's completely because of the friction. So friction between this roller and this workpiece. So because of friction, it will take inside. So if this roller is rotating in anti-clockwise direction, its tendency will be to pull this sheet inside. Similarly, this is rotating in clockwise direction, this lower roller, so its tendency will be to pull this sheet inside. So this will be being pulled inside, and once it will go inside, compressive force from top to bottom, it will reduce the thickness of the workpiece. So you can see from the diagram itself. Here, this is known as initial velocity, and the velocity at this neutral plane, and the velocity at this final. Generally, final velocity is found to be more as compared to the initial velocity. It is obvious also. Okay, now once it will come out, it will be in static friction will be in this area, but here it will be kinetic friction. Okay, na? So because of that, here velocity will be more. In this part, velocity will be less. Okay, so this is the rolling process. So in this, workpiece in the form of slab or plate, okay, is compressed between the two rotating rolls. You can see here two rotating rolls in the thickness direction. This is the thickness direction. Okay, now this is the thickness direction. Okay, now so it's going inside the roll, so that the thickness is reduced. The rotating rolls draw the slab into the gap and compresses it. Okay, it's totally because of the friction, nothing more. Simply we have to put over there, and as the rolls are rotating, its sense is to pull it inside both the rolls. So it will, because of the friction, it will go inside, and once it will go inside from both sides, compressive forces will be there. Its thickness will reduce. Okay, and it's, of course, width will remain same, but thickness will reduce. Okay. Next is the forging operation. Forging operation means there will be a die. So different forging processes are there. We'll see later. So there will be die. Just need to understand, in between the workpiece will be there. So what will do, one die and another die. Suppose at the bottom die here it is fixed. So this is the one die. This is the another die, and this is also known as platen. So what will happen? This is the workpiece in between these two, and from the through the top die will apply the force. If you apply the force, material will be deformed and it will be free to flow. It is an open die, so it will be free to flow. So what will happen? Because of this force, material will be deformed and it will take whatever the shape of the die is, because it will flow and take the shape of the die just like casting. And finally, once it will be removed, it will take the shape of the die and material will be completely deformed and it will take the shape of the die. Okay, so the workpiece is compressed between two dies. Two dies here. This is the top die and this is the bottom die. Bottom die is fixed. Only top die is moving. Okay. So containing shaped contours. Yeah. Whatever the shape we want in our material, so that die will be prepared accordingly. Okay. And once material will be inside, we'll apply the force. It will deform over there, and because of deformation, that deformation force, it will start to flow inside and it will take the shape of the die. So whatever the shaped contour is, it will take over there. The die shapes are imparted into the final parts. Yeah, obviously. Just like bricks, if you might have seen how people are preparing bricks. So in that box, some imprints will be there, some name will be there. Once we are putting over there, so that is being imprinted on the bricks that is prepared. Similarly, in that way, here in die, there will be whatever the shape or the impression we want in our workpiece. It will be over there. And once the material will flow and take the shape of the die, finally it will be imprinted over there on the workpiece. Third one is that is extrusion process. A best example is toothpaste. In the morning, what we are doing for cleaning our teeth, if we are taking paste from the toothpaste, so what we are doing, we are simply applying force at any point, and there is a small opening over there. Through that, paste is coming out. Exactly in same way, this extrusion process works. So you can see here these are the actually die. These are the die, and through which we are forcing this workpiece to move inside through the plunger. We are forcing, and this is the die optics. What is happening? You can see here the dimension of the block. Okay, now its diameter is more, but we are forcing it to flow inside, and it is going and coming out through this one. Just like paste, we are pressing at some point, and there is an opening over there. Through that, it is coming out. Here also this die we are fixed this workpiece, and from the back side we are applying the force, and because of that material is forced to flow, and once it will reach over there, so this die opening is provided. Whatever the dimension or the shape we want, accordingly we have provided the shape or dimension of this die. So we are forcing it to flow through that. So because of that force, it is coming out, and obviously it will take the shape or the size of the die opening over there. So in this, the workpiece is compressed or pushed into the die opening. Yes, pushed into the die opening to take the shape of the die hole as its cross section. Yeah, obviously. So we can see from the diagram, it's quite clear over there. The last one is wire or a rod drawing. Okay. So here we were pushing. Okay. Now here we will pull this one. So here also we have the die. We have the die from both sides. We can see here we have the die. What we are doing, instead of pushing the workpiece, what we are doing, we are pulling the workpiece. So whatever the shape of the die has been given, it is going to take over there. So if it is a tube, it will, the dimension, whatever the dimensions are there, it will take the shape of that one. If it is a wire, so multiple die arrangement will be there, so that wire will pass through the multiple die, and finally its shape will change or its diameter will be reduced over there. So these are the four bulk deformation processes that in detail further we will take, but just for introductory purpose we have discussed these things. Now this classification of a sheet actually forming. So we have already seen, actually broadly four are there. One is bending, one is obviously this deep drawing or cup drawing, and then there is shearing. Shearing is nothing but cutting actually, na, with the help of the die. So we'll see in this is also classified in four parts. In sheet, this is very important to understand that in sheet metal forming was forming and cutting operations performed on metal sheets, strips, and coils. Okay, now the surface area to volume generally is more if we compare with that one in this. Okay, tool includes punch and die. Here also we'll have a punch. Punch means a means through which we'll apply the force, and die of course is the shape that we want. Okay, now so that die will prepare whatever the shape, whatever the impression that we want. Accordingly, we'll prepare the die, and through punch we'll force or apply the force on the workpiece to flow or go inside the die and take the shape of that die, and obviously that shape we want. Okay, so now bending generally happens, means any shape we can produce. Suppose I have to prepare this stylus, I have to deform in a U shape. So what will I do? I'll apply force from the top, and if I'm applying force from here, I will have to give support from both. This is known as 3-point bending. If support is at 4 point, we'll tell this is 4-point bending. So depending upon what kind of support we are providing. So here you can see in the diagram, here is the die and this is the blank we are going to turn, and this is the punch. So what we are doing, initially it is in the form of a rod. Suppose this a small rod is there. Okay, na, and what we are doing, through this punch we are applying the force. We are applying the force through this punch, and this die is having a shape of This is the shape of the die. So what will happen once you'll apply the force? This one is going to take the shape of this one. So this one has taken the shape of this one. Okay. So this is known as bending operation. Okay. So that bending also we'll discuss in detail. Sheet material is strained by punch to give a bend shape, angle shape, usually in a straight axis. It is clear from the diagram also. Then we have deep drawing or cup drawing. In this one, there is a blank holder. So suppose this is the workpiece. Initially, it was also in the form of this one. Okay, now, and with the blank holder, we are holding this, just holding this job here, the blank holder, and then with this punch, we are applying the force. Okay, so once we'll apply the force, this is the die shape. In this shape we want, so it will take the shape of the die. Okay, it is going deforming, and whatever the shape of the die is, it is going to take this one. So in this operation, forming of a flat metal sheet into a hollow or concave shape like a cup is performed by stretching the metal in some regions. A blank holder, yes, this blank holder is simply to hold the sample over there, is used to clamp the blank on the die while the punch pushes the sheet inside the metal. Yes, through punch we'll apply the force and it pushes the metal to go inside the die over there. The sheet is drawn into the hole, taking the shape of the cavity. Whatever the cavity or the die shape we have given, definitely it is going to take the shape of that one. Shearing, as I said, is nothing but a cutting operation. This is nothing but a cutting of sheet by shearing action. Okay, na? So this shearing action, you can see here. This is the blank. Sorry, this is the die. This is our blank that we are going to cut, and you can see here. If we'll apply this force, so it will cut at this point, and finally it will be in two sections. This is the one, and this is the another one. Okay, na? Next is this cold working and hot working. It's very important to understand because whatever the metal forming operation we are going to do, either it will be cold working or it will be hot working. Okay, but most of the processes are generally being done in hot conditions so that a less amount of force will be required to deform the material. But we are going to discuss both and also we'll see what are the advantages and disadvantages. Okay, na? So cold working means simply working at room temperature. Cold working means simply working at room temperature. Means we are deforming the material at room temperature. Whatever the room temperature is, generally 25 degrees centigrade. So we are working material at 25 degrees centigrade. It is known as room temperature. So at room temperature, this is known as cold working. So what is the advantage of this one? So advantage of this one is close tolerance can be achieved. Another one is good surface finish. Why good surface finish? Because if material is in hot condition, so what will happen? Oxide will form on the surface. Okay, na? A scale will form on the surface. If a scale will form, oxide will form on the surface. So obviously surface will become rough. But in cold working, as material temperature has not risen up to that one, it is at room temperature. So scale formation will not be there. Oxide formation will not be there on the surface. So obviously surface finish will be good because of strain hardening. Strain hardening is a phenomenon. What will actually happen whenever a material is being deformed? So what happens? And their dislocation density increase. If dislocation density increase, no need to tell, all the mechanical property almost will increase. So because of the strain hardening, what will happen? Strength and hardness of the part, whichever the part we are deforming at room, is going to increase. That is the another advantage of this process. Grain flow during the deformation provides the opportunity for, yes, directional properties. As we are controlling the grain flow, and of course controlling of the material is also easy because we are working at the room temperature. So whatever the directional property we want to impart in the material, whichever we are deforming, easily we can impart that one. Next is, since no heating of the work is involved, no furnace is there, no fuel is there, no electricity cost, and these things are there. So if this all these things are not there, so obviously cost of the processing will be less. So these things are not involved over there, means furnace is not there, fuel is not there, electricity cost, all these things are not there. So overall processing cost, we can say that if we are doing in cold working, it is going to be less as compared to other processing in hot working. Okay. Machining requirements are minimum, resulting in possibility of near net shift forming. And this is also very, very important. Once you have done the processing, so there will be no requirement of the machining. Means no other secondary operations are required after the processing. So almost near net shift forming is generated. This is very, very important to understand. Okay, now, so here also we can say that it is an economical process because no secondary operations are required. If machining or secondary operations are not required, so obviously whatever the cost, the whatever the expenses or the money we are going to spend in that one, anyway, it is not going to involve in this one. So we can save or minimize those things. Okay. What are the disadvantages of this process? The first disadvantage is more force and power is required. Yeah, obviously. If it is at room temperature, so obviously more force and power will be required. Another problem with this one is at we are deforming the material. So because of the deformation, there will be a strain hardening. So because of a strain hardening, the strength and hardness will increase. If the strength and hardness will increase, then further deformation will become very difficult. So this is the disadvantage of this one. Another one is, as I said, the strain hardening of the amount of forming that can be done. Sometimes cold forming, annealing, and yeah. So that is the second reason. I told there is a strain hardening over there. Because of that, the stress, hardness and strength will increase. So if further or second time or any other time we have to deform the material, it will become very difficult. The workpiece is not ductile enough to be cold worked. Yes. If material is not ductile, then there will be problem in cold working. So for cold working, material needs to be ductile. So these are the three major disadvantages of cold working. Now, what is hot working? Hot working means working above recrystallization. What is recrystallization temperature? As I said at the starting, generally it is more than the half of the melting temperature of the material. This Tm, which has been given here, it is temperature in Kelvin scale that has been given. So generally this is the range. Okay, now again I'm telling this is the range. This is not a sharp point. What is the reason? Because this depends on many things. Whatever the material we are talking about, what is its history, that also need to be considered. History means how it has been cold worked. Okay, now that need to know. So this recrystallization temperature is not a sharply defined temperature point. It generally lies in a range depending upon the history of processing of the material, because on many factors it depends. But generally its temperature is considered as half of the melting temperature to the 0.75 of the melting temperature of the material. Okay, so if we are working or processing the material in between this range, it is known as hot working. Okay, so what are the advantages? As material at a high temperature, so it will be easy to deform the material. So significant plastic deformation can be given to the material. Obviously, if it is a high temperature, it will be easy to deform. So even the small amount of force or pressure will be sufficient to deform the material. So whatever the deformation or plastic deformation we want to give to the material, easily we can provide. Significant change in, yes, as it is easy to deform, so whatever the shape we want to provide to the material, easily we can provide this that one. Lower forces are required as it is at high temperature, so obviously lower force is required, because at high temperature dislocation density decrease, and if dislocation density is less, that means strength and hardness is less. If strength and hardness less, no need to tell, even a small amount of force will be sufficient to deform the material. Materials with premature failure can be hot formed. Yeah, that is that is the main difference between the cold working and this one. In cold working, we have already seen only ductile materials can be deformed. But here, it is not required. Even the non-ductile materials can also be deformed by this. Absence of strengthening due to work hardening. Yes, here there is no problem of work hardening. Means there is no problem of strain hardening. So strengthening is not there in this of hot working. Okay, what are the disadvantages? Short life. Yes, definitely. There will be short life of the workpiece, because at high temperature, everybody knows the property of the material decreases. So obviously, wherever using as an element in whatever application, obviously the life will be less. Another one is bad surface finish will be there. As I said at the starting, if material temperature is high, so scale formation and oxidation is very difficult to control. And if a scale will be formed, surface will become rough. Lower dimensional accuracy, a control will not be there on the dimension, because material is has become very ductile. Okay, now it's very easy to deform, so dimensional accuracy is very difficult to control. Yes, sample surface oxidation. So both will be in this one because of the oxidation and because of the scale formation, surface roughness will be there. So that's all for today. This lecture we will stop here, and in next lecture we'll start with the other metal forming processes. So thank you.